Can you guys hear me? I'm audible. So don't worry about the topic. I won't be boring you how to modernize your data estate. Before I start, I want to know one thing. How many of you are from data background, like database developers, data analysts, data scientists, data engineers? Okay, so that's what I expected, not a lot. So what I did, I was talking to few folks yesterday, and somehow I guessed that this will be the ratio. Only 5 or 4% of the people in the room will be from the data background. So I tweaked my presentation already for you guys. Okay. So when I talk about myself, I'm working in Microsoft as data and AI architect. It's a fancy title, data and AI architect. Although I don't do much about AI, I'm engineer, right? I work in a department called Microsoft Technology Centre. And the presentation, what you have seen just before me, in my day-to-day life, I interact with all the technology from data to digital twin to holograms, holographics, data virtualization, everything, right? When I talk about myself, I'm working in industry for last 14 years, although I don't look that old. All my experience in the data and AI, right? I'm basically from India, and why I'm telling you that I'm from India is I found a lot of resemblance between India and Georgia. Georgian people loves food, so do we. And I realized in the last 2 days they are feeding me like anything, from breakfast to lunch till dinner. And when I reach back to Dublin, I'm sure that I must have gained 2 or 3 kgs extra. Thanks to you guys. One more thing which I found familiar between India and Georgia is the cars don't care about pedestrians. Literally, to reach here, I put my life on the verge to cross the roads. So, and it's not new to me as an Indian, but it's new to me as an Irish guy. Anyways, jokes around. So, don't worry about the slide again. I will also try to cover past, present, and future of the data. One thing you guys must have realized in the previous presentation, that everything is data, from telegraph to digital twin to digital screen, touch screen, everything is data, right? But when we talk about data, in 1980s, everything is very structured. For example, when we talk, what is the meaning of structured data? It means if you can see the data in rows and columns, in form of table, in form of Excel, MS Excel, it means the data is structured, right? So when data is structured, it means it's easier to access. For example, if I give you a table, in the headers are name of the student, age of the student, and salary, or whatever the fees of the student. And all the rows are the number of students in the room. And if I ask you, okay, what is the fee or the salary of a student whose name is Nilendra? Then you will quickly access it, because obviously it's very easy to read. But if I ask you, if I give you a piece of paper in which I just written like salary where somewhere, name anywhere else, and age somewhere else, and I then ask you, okay, what's the name and age of this student? It's tough to access, right? So the first form of data is called structured data. The second form of data is called semi-structured or unstructured data, right? So the legacy systems, which are in 1980s, are working with structured data, right? And when we talk about structured data, it's very easy to access, very easy. But right now, in 20th century, starting from 2001, when we see the data is growing exponentially. So the amount of data, what we have generated till 2000, we are generating almost same amount of data every day. So it means the data, which is the byproduct of the process, is now has the real value. So if we as engineers, if we as Microsoft, or we as different companies, can see the value, can extract the value out of the data, then we can be the forerunner, right? But the problem here is how to get the value of the data if we are still using the old systems. And that's where the thing about modernization of data estate comes in, right? So I'm trying to cover in very low detail, although I need to fly through the presentation. What is that data estate in general term? Data estate is everything in which your data is stored. For example, your databases, MS Excel, files. When you're sending a mobile, it's storing somewhere. When you're sending SMS, when you're calling someone, when you are texting someone, when you are video chatting with someone, everything is data, right? But the problem is some data is structured, some data is unstructured, some data is semi-structured, right? So one more problem, the old systems are not able to get the information out of new type of data. So the problem here is how to upgrade those systems, and before how, why to upgrade those systems? The three reasons. The first reason is these legacy systems which are processing the data are designed keeping in mind 1980s of requirement. So it means they are not able to deal with the current form of data. The second thing is analytics and AI. AI was not a new thing. AI is not a new thing, but in 1990s, 2000, not a lot of companies were using AI. But now these people realize that if they want to stay in the market, they need to use AI. And to need to use AI, they need to use every form of data. And that's where the upgradation is required. The third thing is everyone is moving towards cloud, right? And to move towards cloud, it needs modernization. So cloud means modernization in very general term, right? Now, these are few figures. I will ask you to quickly go through them. So one thing is very clear, right? From all the 4 or 5 figures, that data is important. I'm not going to read them. You guys can read. Everybody is saying the same thing, that, okay, data is very important. 90% of people are saying, if we don't move ahead, we're gonna be losing. The last point is very important. In next 10 years, 50% of the current companies, either they need to modernize themselves or they're gone, right? So, and this is past and this is today. So as I was telling you, in very simple term, in past, data is a byproduct. So what it means, that when we do something, data was generated, and we were storing the data for nothing. We were just storing the data because we need to store the data for some processing. In current world, data is everything. So it's not about storage, it's about getting the value out of the data. So everything that's written there, that's the gist of it. So this is for technical folks, but for non-data people, this is what it is written here in very simple language, right? No. And on the bottom, what we can see, it's a cloud framework. So in 1990s, 2000, everything is on-prem. So it means when companies want to set up their infrastructure, they will buy the system, they will buy the data where databases, servers, and then they will host the databases there, right? And now, when everyone is moving towards cloud, the cloud can be of many forms, right? The first form is infrastructure as a service. So what people are doing now, they are contacting companies like Microsoft, Amazon, Google, and they were saying like, okay, guys, please buy the system for us, and we will pay you the rent. So buy the infrastructure on our behalf, and we will hire that infrastructure, and that's called IaaS, infrastructure as a service, right? Second thing is platform as a service. Now, companies want to move one step ahead. It means they are saying, buy the infrastructure on our behalf, install the software on our behalf, and we will just use the software, and that's called platform as a service. So small companies are paying companies like Microsoft, Google for the platform as well. And the future is function as a service or software as a service. So it means buy the infrastructure, install the software, install the service as well, and we will just write our code. That's all. And even we will just put the, what we say, the play button, and it should run seamlessly. And that's what the future is, right? Again, boring slide. Uh, so what happened when you guys do banking? You guys send some money, or when you guys tap your debit card in the buses, what exactly is going on? That, okay, your current account is debited. The amount which is debited is going to the bus company's account or the government account. So this is called OLTP, online transaction processing, right? But in Georgia, we have 2 million people. Out of them, let's say 1 million people are using buses. So it means every hour, for example, if 15,000 people are tapping those, so it means 15,000 rows are going to a database, update is taking place, the same 15,000 will be deducting the money from other database, right? And now at the same time, as a manager of the bus company, if I ask you that, okay guys, what is the sale for ticket on the route number 364, the bus which goes to funicular, what I used yesterday, right? So you will be like, okay, no worries, I will just write a query, I will hit that database, and everything is good. But the problem here is, if you use the same database which is getting used by the production system, it might get impacted. So it means if you use the same system which is used by the daily transaction, it will not work properly. So we need a system in which we will dump this daily transaction into a new system, and then we will use the data for these kind of reporting. And that's where the data warehousing comes place, right? So everything which is written here is the gist of what I just told, okay? So the data warehouse is a warehouse of all the transactional data, right? Now, the second thing which came out is, so as I was telling you, the newer data is the data of every kind, whether structured, semi-structured, unstructured. The databases are only made for the structured data. So it means if your data has been divided into rows and columns, we can put it into database easily. But what about video files? What about PDFs? What about messages? What about audio files? Where to store this data? Obviously, there's immense value in this data. And that's where this data lake comes in. So as the name suggests, data lake means lake of the data. For example, when we talk about lake, how lake is formed in reality. So there are so many rivers, there are rain, everything. Everyone is pouring data into the lake. And it don't care from where the data is coming from. We are just storing water into the lake. Same is the concept for the data lake. So it means we don't care what is the form of the data. We don't care what is the structure of the data. We don't care what is the velocity of the data. We don't care what is the variety of the data. We just care we need a place where data can be stored. So this is where data lakes comes in. So now we know three things. We have OLTP system, which are real-time based storing databases. We have data warehouses, and now we have data lake. And now you guys know that, okay, there are three types of system, right? Now, and this is where, now, one thing is clear, and since I've told the story, if I ask you question simple, what's the difference between data lake and data warehouse? You guys know the answers now. So those answers are written here. So I'm preparing you for interviews, so just take the screenshot if you want to clear data engineering or data warehouse interviews, okay? So these are the questions which somebody will ask you. So just take the screenshots. But don't tell everything what is written here, just tell them the story and they will select you. Okay. Now, the problem with data lake was that you store the data in any form, but if I ask you to update the data, let's say my name is Nilendra, somehow my name is stored as Rakesh, Raj, whatever, and I ask you, okay, this name is incorrect, please correct it. The problem with data lake is it cannot be done. So there is no update available in data lake, and that's where a new concept called Delta Lake comes in. So what these people thought, like there's a company called Databricks. I'm not sure how many of you heard about Databricks. How many of you heard about Databricks? Okay, so I'll tell you the story again. Everything I'm telling you a story, and I'm hoping it's not very technical. So what happened, Databricks comes with the concept that if we can form a technology which can form a layer over the data lake, in that layer, we can store the transaction. For example, my name was wrong, and I updated it. What was my old name? What was my new name? What was updated? So it's a software layer on the data lake. So in simple terms, Delta Lake is a layer over data lake, right? It can store the transactional, whatever the system value changed, updated, and all. I'm not going there, but this is what Delta Lake is. Now, we know 4 things: OLTP, data warehouse, data lake, and Delta Lake. So now people start thinking, and I think you guys might be still thinking, that what happened that if we mix all these systems, right? See, whether we are coders, whether we are non-data people, data people, everyone can think. Nobody can stop you from thinking. And these people also start thinking that what happened that if we merge data lake and data warehouse in a simple system, in a single system, right? And that's where the concept of lake house comes in. So what is lake house? Lake house is a simple single system which has the capabilities of data warehouse and data lake. Let me simplify it for all the folks here. So you created a data lake, you created a place where you can dump all the data. Now you want the data warehousing capabilities over this data. So you created a delta lake over this data, and now you created a lake house. So what are the features of lake house? That you just need to maintain one system, which can have your structured data, unstructured data, everything, and you have data warehousing capabilities as well, right? Now, don't throw stones at me. People are not stop thinking. Like any technology, people are still keep thinking how we can more simplify it. So the new concept came in called data mesh, right? So what happened in big organizations like Microsoft, in big organizations like Facebook, there are different teams. Some team is working on sales, some team is working on marketing, some team is working on some other thing, right? These teams are specialized in their own domain. So they know their data better than everyone, right? For example, if I'm a sales manager, I know what this value is, right? What is click-through ratio? If I ask you what a CLTP is, you don't know, because even I don't know, because I'm not a sales guy. But sales guys might know this thing. So what I'm trying to prove here, that these people, domain people, know their data better than anyone. So what data mesh is a concept in which you say you don't need a central IT team. You made a smaller IT team across different business units, and these business units process their own data. But they will be using the pipelines or the infrastructure which is built by the central team. So it means central IT is not going anywhere. The data domain capabilities are going across the domains, right? And this is what data mesh is. This slide is interesting. How to implement data sets? Is there some magic wand? So if I go to eBay and I can buy something and data mesh implemented? No. Data mesh is a mindset change. It's an organization change. So you need to bring that thing onto the culture of the company, so that, okay, guys, this sales department is the owner of the sales data, this marketing department is the marketing data, and they are the owner of the data. They need to know in and out of this data. So what this slide is presenting, that, okay, you need cultural shift when you want to go through data mesh. Obviously, we are human beings, and when somebody gives a responsibility, we say, no, we don't want it, right? But we want the value out of everything. So data mesh is saying that, okay, you will get value out of it if you own that thing, right? So don't worry, I'll skip it. So now we know that we have 4 or 5 types of system: OLTP, data warehouses, databases. Now, and we know that if we want to grow, we want to migrate. So now the boring topic starts again. So if we want to migrate, first thing, and this is applicable everywhere, it's not related to data. If we want to migrate something, first of all, we need to know what we want to migrate. We want to discover it, right? The second thing is, we need to assess it. If we discover that, okay, we have these 5 databases which we need the migration, the second thing is, what is the data? Why we need the migration? The third thing is, we need a proper plan. The fourth thing is, transformation or optimization. So for example, if I plan to move the old system to the new system, there should not be a breakage in between. My customers who are using the bus transportation software should be using the software like they're using. They should not care about whether we are moving to system A to system B, where we are moving to cloud or on-prem, right? And this is where the transform and optimization comes in. And the third, obviously, we'll hit the play button, and we will be transforming. So there are 5 steps, and these 5 steps are applicable everywhere, okay? Now, this slide is very interesting, and I'm saying interesting because I really like it. We are human again, and when somebody asks to do some work for us, we will ask the question why, always. Right? For example, if somebody asks me to lift that table from here to here, I'll say, that looks good there, right? Why we need to move it here? Same thing go to the databases. So when we talk about planning, there are some systems in the older systems which can remain where they are. No need to migrate them. The second thing is, there are systems which we can lift and shift to the cloud, or we can rehost them, right? The third type of system is, we might need to change few lines of code, and we can refactor them. The fourth is re-architecture them. For example, when we talk about cloud-native applications, again a heavy word. When we talk about cloud-native applications, they are applications which are written in a way which are specific to cloud. So we might need to re-architect them. Fifth, or last one is rebuild them, right? Third, last 2 are very important and which are very interesting, because whenever we as a developer, we as an architect develop something, it's our baby. We don't want to get rid of it. And that's where replace and retire comes in. When we move to cloud, we need to take the hard decision. This application is no more needed. We need to retire it, or we need to replace it. So these are 7 R's of migration. And these R's are applicable in any migration methodology. It's not about database. It's about any non-cloud technology, right? So when we talk about migration and when we talk about 7 R's, the most important thing, and this is not, again, this is not related to database, this is generic thing. One is how much value that is bringing in and how much efforts we are putting in. So when we see the bottom of here, let's say if somebody asks me to move that box to here, and I'll say, no, that's good here. That's the least effort, because that's there, and I haven't put any efforts. So if that database has been remained wherever it is not bringing any value, but at the same time, it's not having any efforts. The most effort or business value, when we see here, is the peak point when we are rebuilding the application. So if the management decide, okay, guys, from 1st of January 2023, we will be moving to Microsoft Cloud. And then everyone will be like, who will develop it? So it means everyone is thinking about there will be a lot of efforts, but management is thinking there's a lot of value. And that's where the rebuild is on the top part. So this is how 7 R's relates to the business value and the efforts, right? How much time do I have? I'm done? Okay. Again, this is what I have been speaking in the last 20 minutes. We were here in 1980s, and we want to move there in data mesh. And it's not any magic wand. It needs a lot of education. It needs a lot of cultural change. It needs a lot of efforts. And at the same time, it needs a lot of patience. So database modernization, and I didn't talk about Microsoft because I promised myself that I won't be selling anything here. So this is where we want to go, data mesh. Last thing is, when you see the bottom part, all the technologies still lake house are centralized, but data mesh, since we are talking about sales unit, management unit, that decentralized. I'm done, okay? I have few more slides, but I think we are done. So in very simple terms, those 7 R's of migration, business and efforts, all 4 or 5 concepts, if you guys got the understanding from the non-technical point of view, then I can say that presentation is successful. Because the most difficult part is to explain technical things to non-technical audience, and that's what I'm doing day and night. I'm hoping that you guys do get it. Thank you.